how an item typically is expressed is the information that is being transmitted. So what is, it's usually almost always either a signal or a pretense or a past tense of a verb. So let's say this is a pretense of a verb. So we're going to say unprocessed data for this one. That's going in here. And that processes the data. So we're going to say rename element. This processes the data. And then we'll right click on it again and do outputs. We'll create a new item. And we're going to say past tense. Now I need to point out before we continue any further that items are specific to functions. So if this unprocessed data, if you're also using, if let's say this function right here processes other kinds of data, and you go to put an input in there, and you end up with, oh, here's unprocessed data, so I'm going to just go ahead and click that. This is the same exact data that went into function 1.1, and we can see right here that the output of 1.1 is different data. So this should be different data unless these two are like drawing the same information from the same exact spreadsheet. If this function is dealing with any kind of different data than this input right here, then these two need to be changed and they need to be specific. So I'm going to go ahead and do that. I'll click on it and do unprocessed data A. And this is processed data A, so we'll double click on that and do processed data. This way we're very specific. See, now it says data A. That's not what we wanted, so I'll just go ahead and... You can't, when you hit delete, do one thing, if you delete something, if you hit delete like this, do not do that because it'll delete that input from the database. See, watch. There, the whole thing is gone, and there's no way to get it back. So it's very important that you don't delete like that. If you want to get rid of the relationship that input or output has with the function, do not hit delete. Instead, all you have to do is go back to either the properties pane right here, or in the n-squared diagram, right click and edit the inputs. So since I messed that one up by deleting it, I'm going to do let's say this one processes different information. Data B. So now we have to create a whole new item in there. Edit outputs. We'll be very specific with these things. Let's say this function right here uses the processed data from A. It takes that data and let's say it uses this data and it moves a motor to position A, for instance. So how you link that is you right click on this and edit the inputs, and we're going to use processed data A for that. So you get unprocessed data, you process the data, and you send that data to move the motor to position A, function. Processed data B, same thing. Let's say you're moving another motor. Move arm to position B, for instance. So it's taking these two pieces of data and translating it, and you're moving things with it, okay? Now another way to communicate what an input is, or an output, an item. Another way to communicate what an item is it's a signal. It's input 14 volts DC. That could be an input, and this takes that 14 volts DC and converts DC to AC. So the output of that is 120 volt AC. Does that make sense? So this is the actual, this is actually what is being conveyed. You're not going to say wire, you're not going to say, you could say power, you could be very unspecific, and you could just say power. But for this specific example, converting DC to AC, you probably want to be a little bit more specific and say DC power, okay? So you take DC power and you convert to AC power. So now that we have that, I know this is not complete. The real use out of the n-squared diagram is, let me fit this whole thing on here. Go to View, View at Scale, Fit to Window. So that fits the whole thing in the window. The big use I get out of the n-squared diagrams is it's easy to look at the n-squared diagram and see that you're missing inputs and outputs. So right now I can see that function 1.2 is missing an output. I can see that function 1.6 is missing both an input and output. Function 1.4 is missing an output. And I see that none of the functions within this parent function require any of the other functions to loop back on itself. Like there's no refreshing of data or anything like that. Like if we were to send processed data B, if you move the arm to position B, then this information could be conveyed as, let's put a new input in here, is position B location signal is an output out of that. It should have been an output. That's an input. Let's take that off. So position B location signal, let's say position B location signal goes back to function 1.1 for instance. So we're going to go ahead and edit the inputs there. And we're going to do position B location signal, and that shows you looping back within the n-squared diagram. So what I'm going to show you right now is the enhanced functional flow block diagram, and what the enhanced functional flow block diagram shows you is the functional flow block diagram. Remember we did this before, but it incorporates your inputs and outputs onto it. And you can easily move these inputs and outputs all over the place. However it best suits showing your data on here. So you just move these icons around until you can see how it all works and comes together. It's a good way to quickly look and see that everything's got inputs and outputs on it. So you've got DC power coming into this one, getting translated to AC power, going out. And let's say the AC power goes to function 1.6. So you're going to edit the inputs on there. You're going to say AC power goes to that. And the connection's made automatically. So this converts it to AC. The AC power is sent to daughter function 6 and it moves on. So that's basically how the enhanced functional flow block diagram works. So now let me go ahead and show you how to do the functional analysis report. Now just like the requirements analysis report, you're going to do the exact same thing you did for that. You're going to go up here to run a script. You're going to go down here to System Description Document, hit OK, No for primary component. You're going to do originating requirements, design constraints, performance requirements, any of these things if they're on there, but then you're going to include functional behavior model on there as well. So let's go ahead and do that, and then you're going to put I'm going to put enhanced functional flow block diagrams on there, and my n-squared diagrams, as well as, I'm not going to include requirements diagrams. So enhanced functional flow block diagram and n-squared diagrams are the diagrams I want to include on there. So we're going to go ahead and save it. And this is how it looks. So you've got your requirements on there, just like your requirements analysis report, performance requirements.